So in this video, we're going to illustrate how to use the norm inverse function to calculate percentiles for a normal random variable. Suppose you're selling Prozac and you have an estimate that during the next year, the average number of units sold will be 60,000 with a standard deviation of 5,000, and you feel the demand will be normally distributed. You want to have a 1% chance of running out. How much should you make? Well, you should make the 99th percentile. So there's only a 1% chance that people want more than basically what you made. So we can use that norm inverse function to find the 99th percentile basically for the demand for Prozac. Now, using your common sense, you better get an answer that's more than the mean. Okay, if you want to have small chance of running out, you better make more than the mean. So we could do norm inverse. I can double click to put that function in. Okay, so I want the 99th percentile. The mean is 60 and this is 5. The units could be millions or thousands, it doesn't matter. So I get 71.63. Okay, now again we have a picture for this. Let's show you that formula. There we go. Okay, so the 99th percentile with a mean of 60 and standard deviation of 5, let's look down here. The mean is 60, you can see that's where the normal distribution peaks. The standard deviation is 5, so most of it's between 50 and 70. And if you go to 71.63, the area to the right of that is 1%. The area to the left of it is 99%. So that means that's the 99th percentile. Now as another example, let's suppose in a city with a mean income of 30,000, a standard deviation of 8,000, that basically the bottom 10% of the people get food stamps or some form of welfare. So what would be your cutoff for welfare? That would be the 10th percentile, assuming the incomes are normally distributed. So there you would go norm inverse and say 0.1 for the 10th percentile. The mean is 30,000, standard deviation 8,000, like that, and you can see the formula right there. And again, if we had a picture of that, we could look at a normal random variable with a mean of 30,000, so it peaks at 30,000. Standard deviation 8,000 means it's mostly between 14 and 46,000. And if you look at basically 19,748, there's a 10% chance of being less than that. And that's what we got, I believe, 19,748. So now in the next lesson, we're going to talk about the central limit theorem, which is probably about the most important result in statistics. It says basically when you add up 30 or more independent random variables, even if they're not normal, the sum of them will be very close to a normal random variable. This enables us to solve an incredible amount of important probability problems in the real world.